Hey everyone, it's Darren. Welcome. Today we're going to be talking about what to do when you have to compare things that aren't really very similar. For example, you have to compare a bunch of different staff who are working different numbers of hours. They're doing different tasks that take different amounts of time, and somehow you have to still objectively put together your data to compare them and to see how people are doing at the job. And it's not just employment situations. Of course, this happens all over the place. We're just going to use an employment situation because it's an easy one for everyone to understand. We've all been there, right? So to start with here, I have a small delivery company that we're going to be working with today. Just 9 employees, uh, and they do deliveries to different places. Uh, some of them are full time, some are part time. If you look down there, we used to only have 8, and then week 3 we hired a ninth one, Rudolph, who came in. Gotta say, Rudolph's been doing a great job so far. Uh, so let's take a look at how we actually compare these. Now, if we look at the data, uh, we look at the number of deliveries, and this is the first thing that people are going to look at. And you're going to think, well, Prancer's doing great. Um, Dancer, Comet, they're doing pretty well. And, and we got a problem with Vixen. Come over here. Yep, still got a problem with Vixen. Got a problem with Cupid now. Got a problem with Prancer's doing great again. Oh, I see. Dancer was out on vacation on week 3, uh, but wow, Comet did incredible on week 3, and that's all wrong, unfortunately, because if you look at the number of hours they've worked, it's different. And that's the first thing we're going to look at is how you adjust for the number of hours. Um, and that's it's just a data weighting issue. So let's add up the total hours that they worked. And we're also going to add up the total deliveries. So total hours for Dasher is B3 plus D3 plus F3. So he worked 120 hours. Huh? So you can copy that down. And you see we got a really huge discrepancies between the number of hours worked for our different delivery people, or different delivery reindeer in this case, I suppose. Um, but that really impacts the deliveries that they did. So let's add up the deliveries they did. And there's their total deliveries. Now, you may say, wait, how did you do that? And the way the data is laid out, and you'll find this actually works a lot of times that you don't have to retype your data, even when you start doing completely different formulas. Uh, if I look at the total hours here was B, D, and F, I go over one column and that gives me C, E, and G. So that gives me my deliveries here. So now I've got total hours and total deliveries. Uh, Number I want now is deliveries per hour because I can't really. How do you compare somebody who worked 40 or 50 hours to somebody who worked 120 hours objectively? Well, you calculate, how much did you do per hour? So delivery per hour is just J3 divided by I3, principally with an equal sign at the beginning of that, right? Okay. So I'm going to change this format a little bit to make these a little bit easier to read here. So go down to format cells, number, and it's going to show one decimal place is fine. Okay. So here we see, yeah, Vixen's got a problem. Vixen's only done zero point 0.6 deliveries per hour compared to Prancer at 3.8 deliveries per hour. These people are all over the place. Oh, we got a 5.4 down here, 5.4 for Cupid. Um, so are they really that different, though? So if they were all doing exactly the same task, and we looked at these numbers, we'd think we had some definite, good numbers and some definite bad numbers. And you can use standard deviation to figure out the variances and stuff. But just looking, we know Vixen's not doing well, and Cupid down here is not doing well. Assuming they're doing the same jobs, they're not. So in this case, so we've adjusted for one thing using weighting. Now we're going to add a second factor. And you see the second factor is mentioned. Remember, I mentioned these are delivery drivers here. And delivery drivers can have really easy routes and really hard routes. If you're delivering to apartments and condos and office parks, you might take your truck and pull it up to the front door and literally empty your truck at one place. It happens. You have 200 offices that you deliver everything. If you're in a city, you have to drive around a little bit, but not too terribly much. You get out in rural routes, and you're driving. You might drive a couple miles between deliveries, and you get out into the middle of nowhere, and you might be driving 10, 20 miles between your deliveries. So it's really not fair to compare the number of deliveries per hour for that delivery person who's delivering into an office complex where they park their truck and empty their truck compared to somebody who's going out into the middle of nowhere and they manage 10 deliveries over a period of the whole day, uh, but on that day they drove 500 miles to do it. So to do that, what we want to look at is actually adding another factor. And the factor that we're going to add is what I'm calling here a multiplier. And the way this is set up, I defined here route type. This could be work type. If you're doing customer service work, maybe you have phone calls and emails and online chats and walk-in. And different people are assigned to different work, and it all takes a different amount of time. Uh, so now then I added a task number here. And this number is just a convenient index number that I'm going to use to assign to the different delivery drivers. And then a multiplier. So I know that for an apartment, a condo, an office, something like that, uh, I'm saying that they should be able to deliver 3 times more than normal. Uh, City driving, I'm defining city as normal. Now I could have defined remote as normal. Doesn't matter. Just define something as whatever your normal is. Uh, Call that one. Uh, so city, I'm calling normal. If you're delivering to apartments, condos, offices on your route, that should be 3 times as many deliveries per hour. If you're out in the rural area, you're only going to be able to do half as much. You're going to be driving a lot more. You get into remote areas, it's going to be a quarter of what you do in the city. And you just assign these and you put these off onto a separate table someplace. In this case, I just built a separate tab for it. Okay, so what do you do with these? Well, let's go back over here to different hours. Now remember that one is high density apartment, condo, office. Two is city. Three is rural. Four is remote. So so you assign what the tasks are for the different ones. Well, Comet's doing, yeah, he's got this really dense apartment or a really dense office block that he delivers to. He spends all day, he'll drive to 2 different buildings, literally. Uh, and Prancer's not really much different. Uh, Most of them are doing city stuff. And he gets sort of rural, and that's rural. And there's absolute middle of nowhere. Okay, so now I have this. What can I do with it? Well, I'm going to do adjusted deliveries per hour. And to get that, let's put this number here. This number corresponds to this number, which means I want to grab that number. So I want to use VLOOKUP to do this. So what I want to do is I want to take my deliveries per hour, which is K3, and then I'm going to divide that by VLOOKUP, and the lookup value, if you haven't seen VLOOKUP, if you haven't used VLOOKUP, I have a video on it. It's linked down in the description. VLOOKUP is one of the most powerful functions that Excel has. Anytime you're working between multiple sheets and you're trying to pull data between them, you'll want to use VLOOKUP. There's a corresponding function XLOOKUP, which is VLOOKUP's vertical, XLOOKUP's is horizontal. There's a new version, so it has HLOOKUP. There's a new version, XLOOKUP. XLOOKUP is only available, as of the time I'm recording this, XLOOKUP's only available in Excel 365, assuming you have a fairly updated version. So you may see people recommend XLOOKUP for everything. XLOOKUP can do everything that VLOOKUP does. It can do everything that HLOOKUP does, and it can do more, but only if everyone using that workbook is using a reasonably updated version of Excel 365. I still use VLOOKUP. I suggest you probably still want to use VLOOKUP for the most part also, or HLOOKUP if your data happens to be formatted that way. So short version, VLOOKUP. What am I looking for? In this case, I'm looking for the task assigned to that driver, which is going to be L3. The table array, that's where your data actually sits. So I'm going to grab these and do a comma. The column index. Column index, remember this was the table array was B and C. B is where the thing I'm looking up is, and C is column 2. And again, if you get lost in VLOOKUP, it's a little weird. Check out the VLOOKUP video. I spent a lot of time explaining that. And I want an exact match. Then I'll close that. And this tells me that my adjusted deliveries per hour for Dasher is 2.541666, whatever. And again, let's just round this. So I'll just format the cells and pick a number, and I'll take that down to 2, is fine, whatever. Okay, and I'll copy this down. Now numbers look a little bit different, don't they? Okay, so what do we have here? So we have the original data that was collected over several weeks, which included the amount of work, amount of hours worked, and the amount of packages delivered. We adjusted that for the deliveries per hour because all of our staff were working different numbers of hours, so it wasn't fair to compare them because of that different number of hours. And then we adjusted further for the delivery routes because they were doing different jobs. Now, does it make sense to adjust for delivery routes? Well, yeah. If I'm sending my driver out and he's going to be driving 500 miles today for his delivery route, and he only delivers 10 packages, I still had to deliver all 10 of those packages. So the fact that somebody else could deliver 150 packages while he only delivered 10, that's not the driver's fault. That's the fault of the route. So we just adjust for that. And you'll adjust the same way if you have, somebody taking phone calls versus taking emails and doing responses that way. You create the same sort of adjustment, and you can go in and change these numbers. So here, I see Rudolph, who was a rural driver. Yeah, he was rural. uh, did really great. Um, Vixen um, did pretty good still. He's certainly, middle of the pack, middle of the herd, I suppose. Um, but let's say we realize that remote really should be more of an advantage. So I'm going to change remote here, and this is going to be zero point 0.1, and rural is going to be zero point 0.4. So I've just adjusted the weighting here, and obviously Vixen actually is performing best, uh, followed by Rudolph. Rudolph's still doing great. In third place, we have Cupid. So, maybe these numbers aren't quite right because our uh, apartment ones are still the lowest. So you may have to play with your weightings a little bit, depending on what kind of data you have. Uh, if you are doing something like, email versus phone call, customer support, well, you can actually measure how long these things take. I can measure that an email takes an average of 5 minutes to respond and complete the customer service contact. A phone call takes 17 minutes on average, and I can measure those averages, then actually just use those averages. So grab your data wherever you can. If you have to make up data, like I am here for the weights for deliveries, then go ahead and do that, and that's fine. Uh, you could, if you knew an average number of minutes per delivery, you could divide by that instead of just dividing by numbers that we made up. But this is how you do it. If you have people who are doing multiple tasks throughout the day, you can do that instead of having uh, one number of hours and task. Just add a second. So you have, email deliveries and hours week one, and week one phone calls hours and tasks. So that's how you do weighted averaging to actually compare people who are dissimilar. Now that ends up giving you a result at the end. You get a number at the end that is an objective measure comparing your employees. But before we go on with any of that, I want to remind you, if you've learned anything from the video, please hit like and hit subscribe and notify. A couple of reasons for that. One, that's what keeps us YouTube producers motivated to keep making more content. But also, and perhaps even more importantly, that's what tells YouTube, hey, this video is worth watching, this channel is worth watching. The YouTube algorithm sees that and it shares it. So more people can see the content. We also have a Patreon page at patreon.com/data analysis excellence. If you could help out there, just a few bucks a month, that'd really be great. So we covered a lot today, and I don't like my videos to go too terribly long. So we're going to stop here for today. Uh, there's a lot more you can do now that you have this number that's relatively objective, that's comparing your staff, and you've tweaked the numbers down correctly. That's where you'll start to pull in things like standard deviations and quotas and that sort of thing to uh, actually use that objective number to actually allow you to compare your staff, determine who's doing a good job, who's doing a bad job, who gets a big bonus, who maybe just needs a little extra training. Uh, but that's a topic for another day. So again, like, subscribe. You'll see when those videos come out, and I look forward to seeing you there.